Hello guys, welcome to Sergei's Physics. Today I'm going to talk about vectors. And what are vectors? They come in physics first of all because of forces, because you have to add forces acting on the bodies. And forces, if its force is some push or pull, then it would have a direction. It depends where it goes, and also obviously it's important how big it is. So vectors are mathematical quantities, mathematical ideas, yeah, which have direction and magnitude. Direction and magnitude, how big they are. So it's nice to represent these ideas with something on the whiteboard, for example. So we can represent a vector as an arrow like that, which have a base and which have a tip. And you see there is magnitude. Magnitude corresponds to the length of the vector which I have drawn, and obviously direction, it shows where it is. We can specify it a little bit, showing the angle, say alpha, to the vertical. Okay. And how long it is, and then we can draw it. Okay, now, how to add vectors? Obviously, you can add the vectors easily if they are going in the same direction. You just put the tail of one to the tip of another, and the resultant one would be the sum of the vectors. So this line joining, you see, the base of first with the tip of the last is the sum. So if this was A and another was B, and here is C, we can write C is the sum of A and B. Easy? What if they go in opposite directions? Okay, let's try something. And this one, yeah, again it's A and this is B. What we are going to do? We are following the same idea. We put the base of one to the tip of another, and the order doesn't matter. So we're just doing it, we redraw and we put B here. And what is the sum? The sum is, again, I'm joining the base of the first with the tip of the last, and this vector is vector C is the sum. Again, I can write C is equal to A plus B. Yeah, easy. If they're in the same direction, you draw the vector as big as the sum of their lengths in the same direction. If they're in opposite directions, you subtract their lengths from each other, and you draw the vector in the direction of the biggest one, with the length as a result of subtraction. You see what I did actually? I subtracted A from B, and this is the C, which is the leftover. What if they are in arbitrary direction? Yeah, they shouldn't go in the same, no? Vectors are free. What if we have this company of vectors? This is A, and this is B, and this is C. How to find their sum? Again, we just join base of one to the tip of another. We just combine them. You see, why this makes sense? Simplest vector could be what we call displacement. Just imagine this is the way how the person is transferred from one point to another. And then he transferred a little bit here, and then he transferred a little bit here. So these are his steps. Whatever the order of steps, he would arrive essentially at the same place. That's a bit strange idea, but let's try it out. So let's start with A, B, and C, D, yeah? So that's our A, that's our B, I believe, and that's our C. Yeah, I'm trying to keep the length as correct as possible, and that's our resultant vector. Yeah, say D, and that's the sum. I added A and B and C. What if I start with C first? Well, why not? Let's try C, and let's add B, and then A. And what's the result? The result is the same D. You see, nothing changed. So D, yeah, is the sum of A and B and C, and you can put it in the same, in any order. It can be C, it can be B, it can be A. The result is the same. So that's how we draw it. We just, if we have to add vectors, we put them in chain, putting the base of one to the tip of another, and then we're joining the base of first to the tip of the last. In physics, though, you have very often to add just two vectors together. So how do we add them? Again, A and say B. The only thing we know about them is their direction and their magnitude. They are not fixed at any place. Vector doesn't have position. Vector has a length, but it is the same vector anywhere. In physics, it's sometimes pretty important where the vector is applied, but it's a bit different story. Vectors as itself don't have a position. So we can take this vector and put it here if you wish. Yeah? So we redraw it. We redraw A. And then we put B at its tip. And then we just complete the triangle, joining the base of the first with the tip of the last, and that's the sum. C is the sum of A and B. This is called the rule of triangle. Yeah? It's easy. Yeah? It's just two of the vectors, and you can draw a triangle like that. First you go sequence of two vectors. Again, it's absolutely the same. It's unessential which one you start first. I can start with B, and then I go, and then I do A. I would still get the same C. It doesn't matter, yeah? The order is not important. It's important that you just go them in a sequence, in a chain. This is triangular rule, yeah? Triangular rule of adding vectors. Sometimes it's more convenient not to do them tip over tail, yeah? It's better if these vectors start at the same spot. Okay, let's try to do it where they start at the same spot. Here is my A, and here is my B. What can I do here? I just do make a parallelogram. You see, what is parallelogram? It's a figure with four sides, and two opposite sides are parallel to each other. So I'm doing this. You see, you can notice that this is exactly with the length B, and if we draw the direction, it would be exactly the vector B. According to triangular rule, the sum of A and B would be this line. This line is diagonal of the parallelogram which we draw. So this is parallelogram rule. Parallelogram rule of adding vectors. Again, we draw them from the same dot, from the same position, and then we extend parallel sides, parallel to each vector, to draw a parallelogram, and the sum of these vectors is just diagonal. Again, you see, these are identical ideas. A, B, C. C is the sum. Okay, that's it for simple idea of adding vectors. See you next time. Subscribe to the channel. Bye.